Okay, so we're now going to start working the odds, and you will work the evens on your own for homework on these specific heat problems. So you're going to want to go on and have the specific heat problems number one that you have out. And you're going to want to have your cheat sheet. This cheat sheet right here, and you have that in your packet that I gave you the first day of school. So if you could go on and get that out along with um, a calculator and some notebook paper, because I would like for you to put your work on notebook paper, and you're going to turn your notebook paper in with your answers. Okay, so do not try to write your answers on this piece of paper that's uploaded, because there is not enough place or room for you to put your work. Okay. So let's take a look at number one. So, number one says, how many calories of heat are required to raise the temperature of 1 kilogram of water from 10.2 degrees Celsius to 26.8 degrees Celsius? So, when you're solving these problems, I always say to make a list. Just like when you're working with the density problems, you hopefully made a list of D equals N equals and V equals. So, we'll do the same thing with this one. So, we'll go delta Q, M, C, and delta T. So, it wants to know how many calories. So, calories is going to be delta Q. Okay, delta Q right here is your number of calories. So that is what we are trying to find. So we're going to put question mark, small calories. Our mass is going to be 1 kilogram of water. So M is 1 kilogram. But please notice on your sheet that mass has to be measured in grams. So we can use the King Henry method to move our decimal place 3 places over. So that's going to equal 1,000 grams. C. So it specifically said we have 1 kilogram or 1,000 grams of water. So when we're looking at our specific heat will be the 1 calorie or the 4.184 joules. But since it said how many calories, we're going to use this number here for C. So the 1 calorie over grams times degrees Celsius. I'm going to move this down some. Now, to find our change in temperature, we're going to take our final temperature minus our final minus our beginning temperature. Okay, so final minus beginning. So it says the water went, so it started at 10.2 and it went to 26.8. Okay, so our change in temperature of water is 16.6 degrees Celsius. Now we are going to figure out which formula will we use here. Well, since we're solving for delta Q, we're going to use our first formula and we're going to plug in and solve. So our formula is delta Q equals MC delta T. So M is 1,000 grams. C is the 1 calorie over grams times degrees Celsius. And your delta T is the 16.6 degrees Celsius. So this is why the specific heat has this many units, because the grams cancel, the calories cancel, I'm sorry, degrees Celsius cancels, and you're left with calories, which is what you're trying to solve for. So now pretty much all you're going to do is you're going to multiply 1,000 times 1 times 16.6 to get your final answer of delta Q. So we have 16,600 small calories. So let's move on to number three. Number two is going to be worked out just like number one, where you're solving for delta Q. So number three says, what temperature change will 100 milliliters of water undergo when it absorbs 325 calories of heat? So make your list. Okay, so we know delta Q is going to be calories. So are we given a calories in here or joules? Yes, we're given a calories. If we were given joules, then we would write joules or numbers per joule. But since we're given 325 small cals, that will go here. We have 100 milliliters of water. Now, the really cool thing about water, and I don't know if you remember this when we studied the metric units, but water has the mass of 1 gram that's equal to 1 milliliter of water. So it's a 1-to-1 relationship. So if we have 100 milliliters of water, that means we have 100 grams of water. So that's a pretty cool thing about water and why water is so easy to also work with here because it's 1-to-1. So C is going to be our next thing. So since we are looking at specific heat, and it specifically says of water, we will either use the 1 calorie or the 4.184 joules. And since has already given us the calories, 325 calories, we're going to use the 1 cal over grams times degrees Celsius. If we were given joules for delta Q, then we would use this number here, the 4.184. Okay, so we're going to find our change in temperature here. So this time, as we look at our formula, since we're solving for delta T, we're going to use this formula here, our heat or delta Q over M times C. So I'm going to just put delta Q here. So delta Q is 325 calories. Your mass, 100 grams. And your specific heat is 1. Okay, so this time you're going to see with your specific heat that your grams, they cancel, calories, they cancel, and you're left with degrees Celsius. So again, this is why your specific heat has all of those units. So 100 times 1 is 100. So we'll take 325 divided by 100, and that's going to give us 3.25 degrees Celsius for our change in temperature. So number three is going to be set up and solved like number four. Again, in number four, you're saying what is the change in temperature if you have 422 calories of heat and it's absorbed by 80 milliliters of water. So remember, water is a 1-to-1 ratio. So if you have 80 milliliters of water, you have 80 grams of water. Number five. So, number five, what is the final temperature if you have 45 milliliters of water at 15.4 degrees Celsius and it absorbs 2.50 times 10 to the second calories of heat? Make your list. Okay, so you have 2.50 to the second calories, which is the same thing as 250 calories. If you don't like exponential numbers, okay? So remember, we said delta Q is your calories or your joules. So we are given our joules. So let's move down to our mass. Are we given a mass here? We're given 45 milliliters of water. So 45 milliliters of water is the same thing as 45 grams of water. And since we're working with water, we're going to use the specific heat of water. And we can either use the 1 cal or the 4.184 joules. And since our delta Q is measured in calories, we're going to use the 1 cal over grams times degrees Celsius. And we're going to find our change in temperature, and then we'll use that because I know we're given 15.4 degrees Celsius. But that is our beginning temperature. It's saying what's the final temperature. So we don't want to put 15.4 here. So number 5 actually has another step in it. So we're going to use the delta T formula. So the heat over MC again. So delta T over delta Q, or your heat, times M and C. So we have 250 calories, and our mass is 45 grams, and our specific heat is the 1 cal. So our grams, they cancel, calories, they cancel, and we're left with degrees Celsius, what we're solving. So 45 times 1 is 45. So 250 divided by 45 is going to be 5.6 degrees Celsius. Okay, so that's our change in temperature, but it wants to know what is our final temperature here. So it says that it's absorbing water, okay, or excuse me, it's absorbing the heat from the water. So we're beginning temperature is 15.4 degrees Celsius. And this is our change in temperature. Absorbing means to take in. So that means we're going to add 21 is going to be 21 degrees Celsius. Okay, so that is going to be our ending temperature or final temperature. So number 5 is going to be a model for number 6. Now, what I'm going to tell you about number 6, if we look at it, it says what's the final temperature. Again, the same thing, we're going to solve for delta T, even though we're giving the beginning temperature of 80 degrees Celsius. But what we're going to do with that is that it says that the heat is released. So it's losing, the reaction is losing it. So we're going to subtract whatever we find our delta T to be from 80. Number 7, what is the quantity of water if it's heated from 25 degrees Celsius to 36.4 degrees Celsius by absorbing 325 calories? What is the mass of water? So go on and make your list. So are we given something in calories or heat? Because remember, delta Q is referring to calories or joules. Yes, we are. We're given 325 calories. We are trying to find our mass. So we'll put question mark grams because it says the quantity of the water. So how much water do we have? C, since we are using water again, and our Q is measured in calories, we'll always use the 1 cal or the 4.184 joules. But since we're using calories here, we'll use the 1. If this was measured in 325 joules, then we would put 4.184 joules over grams times degrees Celsius. And then we're going to find our change in temperature. Okay, so our change in temperature is going to be 11.4 degrees Celsius. So since we're solving for M, we're going to go to our cheat sheet and find our M formula. So that's going to be our heat over C times your change in temperature, or what my past students have referred to as the CAT formula. So the heat, or delta Q goes on top, and specific heat and change in temperature will go on bottom. So 325 cals all over 1. And our change in 11.4. So this time your cals, they cancel, degrees Celsius cancels, and you're left with grams. So 1 times 11.4 is 11.4. So 325 calories divided by 11.4, and you get the mass of 28.51 grams. Okay. So 7 is going to be a model for 8. Notice that it has it in 1 kilocalorie and number 8. So you will need to convert your kilocalorie over to small calories. So remember, 1 kilocalorie has 1,000 small calories. So for number 8, your delta Q is going to be 1,000 calories. Let's take a look at number 9. Make your list. So your delta Q, it says, what is the specific heat? So we're going to just put a question mark here. Of lead. So notice we're not working with water in this one. If we have 30 grams, that undergoes a 250 degrees Celsius change. So it already tells you what your change in temperature is. You don't have to find it. And it's absorbing 229.5 milliliters. Okay. So when we're solving for specific heat, we're looking at our C formula. We call it the MAT formula. So heat over M times delta T. So our delta Q is 229.5 cals. Your mass is 30 grams. And your change in temperature is 250 degrees Celsius. So this time, your units are not going to cancel out, but they're going to come together to give you your specific heat. So the first thing we're going to do is we're going to multiply the bottom. So we're going to take 30 times 250. And that is okay. So that's 7,500. And then we're going to take the 229.5 divided by the 7,500, and C will be okay. So C is going to be 0.0306 cals over grams times degrees Celsius. Um, Number 9 is the model for number 10. And in number 10, it shows 1.00 times 10 to the 3. That is a dash, not a negative gram. Okay, because you can't have any negative mass. So we'll go on and check the odds tomorrow.